Welcome back, my dear students. So, in this lecture, I will take up some problems to build up the understanding about the concepts of translation, scaling, rotation, reflection, and sharing. So, we'll start with certain problems. So, I have taken one problem that is, for example, problem first, A part. Given a circle C with radius 10 and the center coordinates are given 1, 4. So on this circle, we have to apply the transformation, that is the translation, with the distance of 5 units towards the x-axis and 1 unit towards the y-axis. So in this means simply, if I'll take up the A problem, so the tx is given as 5 units. This is the translation factor, or you can call it as a shift factor or a translation vector, or the circle is moved by in x direction by 5 units moved by, so ty is equal to 1. So how we are going to solve this, that how we are going to shift the circle with radius 10 given with the center coordinates 1, 4, and where it will be placed after translation. So simply for this, we will use the, in every question I'm going to use the homogeneous coordinates matrix. Okay, that is your 3 into 3 order matrix of whether I'm performing translation, whether I'll do the scaling, reflection, or any kind of thing I'll do. Okay, or any kind of transformation that will be performed will be taken up with the 3 into 3 order matrix every time. Okay, so I'll calculate the new center, that is the C dash is equal to, okay, first I will write the matrix of the translation, because this translation matrix has to be applied on the center of the circle. Okay, so center of the circle has to be shifted. Okay, so the center of the circle is 1, 4, okay, and 1. Okay, so how I will write it in general form, that is new point and the translation matrix and the old point of C, that is the center. Okay, so translation matrix is this, center point is this, and the new point, that is this, and the new point can also be written as, in terms of x and y, that will be x dash, y dash, and 1. Okay, so what will be the translation matrix of 3 into 3 order, that is 1, 1, 1. Okay, that is tx. So I am directly writing over here, tx is 5, okay, and ty is 1. So after multiplying it, we will get what, 1 plus 0 plus 5. Okay, that will be 0 plus 4 plus 1, and 0 plus 0 plus 1. Okay, so that will lead to 6, 5, and 1. So new center point of the circle will be x dash, y dash, 1 will be equal to 6, 5 1. So C dash is equal to, okay, so C dash new center is 6 comma 5. So simply how we receive the Cartesian coordinate values from the homogeneous coordinates, simply 6 by 1, 5 by 1, that will 6 by 1 and 5 by 1 will lead to the 6 comma 5, 6 comma 5 as the center of the new circle. Now if I show it you with the help of a graph, okay, so before translation the circle was drawn at a center 1 comma 4. For example, at x this is 1 and let's say this is 4, okay. So at this position the circle was drawn with the unit of 10, that is the r was equal to 10, okay. Now the new points are generated, means the circle has been shifted by value tx is equal to 5 and ty is equal to 1. So the circle will be placed at different location, that is 6 and 5. So 6 is the, let's say this is 6, okay, and this is 5. So now this is the center, okay. Now at this place the circle will be redrawn with the same radius, okay. R will be equal to 10 and the center is 6 comma 5. So here you can see that translation means simply shifting an object from one location to another location. So it is not going to change the shape of the object. The shape of the object will remain same and it will be redrawn at different location, means simply it is shifted by certain value. So it will be same applicable for the ellipse. If the ellipse is drawn, if the ellipse is given to you, so you are going to shift the circle or shift the ellipse to a different location, okay, with that center point, and the ellipse will be redrawn, okay. So now I'll take up the second problem, that is B part of this problem, okay. In this the different shape is given to you, that is a square, okay, and the coordinate points are given A, B, C and D. Now we have to apply the same, that is the translation matrix or translation with the distance in x towards x is 1 and in y also we are moving with 1 unit. So obtain the new coordinates. So it is very simple. Now we are trying to say that you are given with a point a dash, you are going to calculate the new point, that is a dash, okay, and this will be given with x dash, y dash and 1, okay, and that will be equal to, I'll write directly with it. Now we will follow this step only, that is the new point, that is p dash matrix, that is a translation matrix, and the old point, okay. So this will be applicable to each and every point of the square, okay. A, B, C and D, all points will be translated. So here I am going to write the matrix 1 1 1, okay, 0 0 0 0. The translation value is 1 1, okay. So this is tx is given 1 and ty is given 1, okay. So the our translation matrix will be this, and the point for A is 0 3 1, okay. So after multiplying and calculation you will get what, that is you will get 1, okay, and what 3 plus 1, that is 4, okay, and then 1. So this will be the new point. Likewise B dash, okay, B dash I'm writing directly over here. So the same matrix will be taken here 1 1 1. Okay, and I'll take the B point. B point is this. So here 3 3 1, and the new point will be what? That will be your 4 4. This likewise I'll go for the C dash. Okay, in C dash I'll put the matrix again of the translation. Okay, that is 1 1 1 1 1. Rest of the points will, rest of the matrix values will be 0, and then I'll put the point of C, old points that are 3 0 1. Okay, after multiplying these two matrices you will get 4 1 1. Okay, and then after that I'm going to calculate the D dash. That will be again the translation matrix 1 1. Okay, now the D is 0 0 1. New points will be 1 1 1. Okay, so these are the new points after translation by tx is equal to 1 and ty is equal to 1. If I try to draw the figure, for example, the points are given with this a03. Okay, so this is 0 and this is 3. Okay, so 03 is this. Okay, 03 and 33. Let's say this is 33 33, and this is 30, and this is 00. So these are the points. So originally your object or a square was placed at this location. Now it is shifted by 1 unit in x and y. Okay, so the new points are 1 4. You have, let's say this is 1 and this is 4. Okay, so 1 4 is the first point. Okay, this is 1 4 is the first point, and let's say this is 4, and this will be your 4 4. Okay, then you have 4 1. 4 1 means simply 4 1. Let's say this is 1, so 4 1 is this, and 1 1 is this. Okay, so this point join with this. So means this object square is shifted from these coordinates a, b, c, and d. The new coordinates are a dash, sorry, this one is a dash, b dash, c dash, and this one is d dash. Okay, so means this object square is translated by 1 unit in x direction and y direction, and it is shifted by 1 unit. So the new locations are given with a dash, b dash, c dash, and d dash. Okay, so here also you can see the shape of the object is not changed. Okay, the lines are preserved in the same manner. the distance between the two lines are preserved and the body is rigid. So this is the translation of a square with one unit, x and y. Now I think it would have been easy for you to understand now. So what is translation and how we do the translation. Okay, now we will move ahead with the second problem. Okay, so what this second problem says, and it covers up the concept of covers the concept of the scaling. Okay, so in this a square is given. I have taken a square of the same values which I have taken in translation, that is a03, b33, c30, d00, and we are applying the scaling parameters. A, that is your 2 towards x-axis and 3 towards y-axis, and obtain the new coordinates of the object. So object is the same, that is this. Okay, so 30, okay, 33, sorry, it is 0, 30 and 00. Okay, now I have to scale this object by sx is equal to 2 and sy is equal to 3. Okay, so we have already gone through the scaling matrix sx, sy, okay, or 3 into 3 order, and I have already covered the concept of when we enlarge the object, when we decrease the object, okay, and when the uniform scaling take place and when the differential scaling take place. And also I have covered the concept of when these parameters reaches to the negative values, diagonal values, when these parameters reaches to the negative values, it leads to the reflection. Okay, I have already covered it. So we will solve the problems related to the reflection also ahead of it. So first taking up the a part of this problem, that is sx is equal to 2 and sy is equal to 3, means we are scaling this, we are going to scale this object in x direction by 2 units and y direction in 3 units. So as you can see, when sx and sy are greater than 1, then enlargement, object will enlarge, means the size of the object will increase, as well as the values are not same. Sy is scaled by 2 units, whereas sy is scaled by 3 units. So these values are different. So this scaling will be of what kind? That will be of different, that will be of a differential scaling. Okay, so let's solve it and see where our object will be placed with new coordinates after performing the scaling when sx is equal to 2 and sy is equal to 3. So rest of the parts I hope you will be able to do once we are completed with the a part. Okay, so let's see. Okay, so this is a, this is b, this is c, and this is d. Now let's calculate the a dash. A dash is equal to In general form I can write it like scaling matrix, then old point P, and it will give you the new point P dash. This is the general point, and this scaling matrix will be applied to all points A, B, C, and D all. So A scaling matrix, I'm directly writing the values over here. Okay, first you will write the scaling matrix over here, Sx, Sy, and Sy. So let's write the values of scaling factors, that are 2 and 3, then 1. Okay, and the values are old value of A is 0, 3. What will be the answer to this? That will be 0. Okay, and that will lead to 9. Okay, and sorry, this will lead to 9, and this will be 1. Rest of the points will be 0. You can simply calculate it by multiplying it. Okay, then B dash, again I'm going to write the matrix 2, 3, 1, and points of B is 3, 3. Okay, and new points will be 6, 9, and 1. Sorry, I have written wrong for it. This will be the order of 3 into 1 because we are multiplying with it, and all these values will be added. I should write like this. Okay, so it will be simply 0, 9, and 1. Okay, and in the same manner this will be written as 6, 9, and 1. Okay, after multiplying you will get this. Then B dash, then C dash. Again write the scaling 2, 3, 1. And the point is 3, 0. Multiply it, you will get 6, then 0, then 1. Now calculate the values of D dash. Okay, same. You write the scaling matrix 2, 3, 1. The rest of the values are 0. And write the point of D, old point 0, 0. And you will get 0, 0, 1. Okay, so I told you that when Sx and Sy is equal to 2 and Sy is equal to 3 means the value is of Sx and the values of Sx and Sy are greater than 1. So the enlargement of the object will take place, and this object will also be, because this enlargement will take place with respect to the origin. Okay, with respect to the origin. So means enlargement will take place, means this object will move away from the origin. Let's see where it lies. Okay, A dash, that is 0, 9. So this was your 3. So let's say this is 9. I think 9 is the highest one. Yes. So let's say this is 9. Okay, so 0, 9. So this is the point. Okay, next is C9 6 9, that is 6 and 9. Okay, 6 9, then 6 0, 6 0. We are here only at the same point, and 0 0. So this is, so you can see, let's draw it here, otherwise it will overlap. Okay, let's actually, now here you can see. So here one more point I want to make over here, that when the object is placed, when the any vertex of the object lies at the origin, so no translation take place when scaling is done. So this is also important point to note with this figure. So it is done with respect to the origin, but your object lies at the origin, so it is not moved or it is not translated, means it is not shifted when the scaling is taking place. Okay, so if the object would have been at some other location, so by default the translation will take place with the scaling. But when the object is placed at the origin, so no translation take place. Same goes with the rotation also. Okay, if the object is placed at the origin and we try to rotate this object, then the object will be rotated about origin only. Whereas if the object is placed somewhere else, okay, and we try to rotate, so by default the translation will also take place with the rotation. Okay, same goes with the scaling. So in this case the object is placed at the origin, so that is why it is not moved away from the origin. Okay, so just this thing you have to keep in mind while doing the scaling, that no translation take place or no translation take place in both cases of rotation as well as scaling when the object is placed at the origin. And if the object is not placed at the origin, then by default the scaling as well as in rotation the translation will take place. Okay, so this is the case for the differential scaling, and enlargement will take place. Now let's go with this B part, and you can easily, I'll just theoretically explain you, the rest of the calculations you will do on your own. So this is the Sx. In this case Sx is equal to Xx is equal to 4 and Sy is equal to 4. So this is the case of uniform scaling because Sx and Sy are equal. Okay, and uniform scaling, and object will the size of the object will increase because it is greater than 1. Okay, when I'll take up the B case, C case, that is Sx is equal to 0.5 and Sy is equal to 0.8. Okay, so in this case Sx and Sy both are lesser than 1, but the values of Sx and Sy are different, so it will lead to the differential scaling, but the decrease of the size of the object will decrease. Okay, when I'll take a B part, so in this case the Sx is equal to 0.5 and Sy is equal to 0.5. So in this case Sx is equal to Sy, both are equal, so the uniform scaling. So this is the type of uniform scaling. Okay, and the size of the object will decrease because Sx and Sy is lesser than 1. So in the previous example of this A part, you have seen the size of the object was increased, but the shape of the object has got changed. It was square and it was changed into the rectangle. Okay, so the shape of the object was changed. Is it clear? So while doing the scaling, the shape of the object may get changed according to the type of scaling you are performing. Whether when you perform the differential scaling, the shape of the object will get changed. When we will perform in the proportionate manner, the scaling will be done in case of the uniform scaling. Okay, so in the same manner, in the proportionate form, the value will get. So in this case, if we will perform a uniform scaling, so the square will remain square, the values will get changed, the size will reduce, but the square will remain square when we will perform a uniform scaling, whether we are decreasing the size, whether we are increasing the size. So square will remain square. When we perform the differential scaling, means the size of the object may get changed and it can acquire the different shape while performing the scaling. Okay, so I think I should stop here, and then I'll prepare with the new lecture that will cover up the concept of rotation, reflection, and shearing. Okay, so I hope that you would have understand this lecture. Thank you all. Welcome back, my dear students. So in this lecture, we will cover up the rotation, shearing, reflection. Okay, and some concept regarding the classes of transformations. So this problem 3, and if we look into the A part, so it says that a line segment is given to you and the starting point is 0 0 and the end point is 4 4, and now you have to apply the rotation that is in anti-clockwise direction on the line segment. So simply we have to perform the transformation on the line, that is rotation, and this line has to be rotated by an angle 30 degree, and we have to find the new coordinates after rotation of that line. Okay, so how we will proceed to solve this problem? So let's take up the A part. Okay, so in rotation, what is the rotation matrix? First we will write the rotation matrix, that is your cos theta minus sin theta. So we will always use now 3 into 3 order matrix. Okay, so cos theta minus sin theta, sin theta, cos theta. So this matrix we are going to use, that is your 3 into 3 order matrix or homogeneous coordinate system matrix. Okay, so this matrix we are going to use, and in general form if I'll write, so how the new point will be calculated, that is P dash, then the matrix, rotation matrix, then the old point. Okay, so this rotation matrix will be applied on each point of the line to calculate the new coordinates of the line. So let's say the line is with point A, that is 0 0, and B point is given with 4 4. So simply we have to calculate the A dash and B dash. These are the new points after a rotation. So A dash will be rotation matrix cos theta minus sin theta. So let's write the directly the angle of it. By what angle we have to rotate, that is theta is given over here, that is 30 degree. Okay, so I am writing over here that is cos 30 degree minus sin 30 degree 0 0 1 sin theta, that is sin 30 degree. Okay, okay, and what will be the points of, what are the old points of A is 0 0. Okay, you can easily see that the points are given 0 0. So simply when we multiply you will get 0 0, but still we will write the values of the cos 30 degree minus sin 30 degree so that it can be used further. And you should know that how you are going to solve the problem, because you cannot say directly over here that is 0 0. You have to put the values of cos 30 degree. So what is the value of cos 30 degree is 0.8660, okay, minus 0.5, 0.5, 0. The points are after multiplication you get this. So A dash is 0 comma 0. So the points remain same. Now we'll calculate the B dash and directly write the rotation matrix. We know this rotation matrix. Okay, first you will write over here, then you will put the values. So I'm writing directly the rotation matrix is this. So we'll put 0.8660, okay, minus 0.5, 0.5, we'll keep the old points of B, that is B, what is B over here, 4 8 4 4 1. After multiplying these two matrices we will get 1.464 and 5.4. So B dash is 1.64 and 5.464. Okay. Now we'll try to draw the figure and see where the object is placed after rotation. Okay. So at 0 0 the line was placed originally, and this is your A point, okay, and B point is 4 4, so this is 4, and Y, this is also 4, okay. So line is drawn from here to here, okay. Now after rotation by 30 degree, the new points, that is 0 0, that is your A dash, okay, A dash, and the new point B dash is 1.464. Let's say this is 1 and this is 2, so 1.4 will lie somewhere here, okay, 1.4 and 5, let's say this is 5, this is 6, so 5.4 will lie somewhere here, okay. So the point is somewhere here, let's say, okay. So the new point or new line, so this is B dash, and the points are 1.46, 1.46, and the points are of A dash will remain same. So this line is rotated by an angle of 30 degree. So these are the new coordinates after rotation of a line by an angle of 30 degree. Now you can see the degree of rotation is given anti-clockwise direction. This you have to keep in mind while solving the problem. If it is given clockwise, then you have to take theta is equal to minus 30 degree, and by taking angle minus 30 degree you have to solve the problem. So whenever the rotation is anti-clockwise direction, it will give you the angle, you have to take the angle in positive values, and when the degree of rotation is clockwise direction, then it will always lead to the negative values of rotation, okay. So this is the positive rotation, that is the anti-clockwise direction, and this is the negative rotation, that is the clockwise direction, okay. So this you have to keep in mind. So here you can see, again I told you that whenever the rotation take place, the displacement or the translation by default take place in case of the scaling and the rotation, but still the translation doesn't take place by default in this case. Reason being because the rotation is done with respect to the origin, and one of the point lies on the origin, okay. Let us solve the same problem, okay, by having the line at different locations. So let's see where the line will be drawn. Means the complete line has to be translated if it is given at different points beside it is not lying on the origin. So let's take up the line that is starting with 1 1, okay. So let's redraw the figure and see where the point will lie. So what I am trying to say in this I'm saying that earlier we have taken a line that is at 0 0 or somewhere 4 4, okay, and we have rotated this line by an angle 30 degree, and the degree of rotation was anti-clockwise. That is why we have taken theta is equal to 30 degree. If it would have been given as a clockwise direction, then you have to take the angle in negative value, that is theta is equal to minus 30 degree. And I also highlighted it that whenever the rotation and the scaling take place, by default the translation take place. Okay, so object is shifted by certain value, that is the by default it takes place. Whereas in this case, the line is not translated. Okay, it is only rotated, because one of the point, whenever the object lies at the origin, so no translation take place in scaling as well as in rotation. So I have shown you in the case of the scaling, when the rectangle was enlarged, okay, so no translation took place in that case. Okay, let's see. if i if I take a line, okay, and the, let's say line is this, okay, and this is one, this is one. So the new point A is given with 1 comma 1, and B is given with 4 comma 4. Okay, now when we calculate the points, so according to the principle, when the object is not placed at the origin, so the translation should also take place when we are performing rotation. Okay, so again let's calculate the A dash. Okay, let's calculate the A dash. A dash will be matrix of rotation, that is simply your, I'm directly writing the values of sine theta and cos theta, that is cos 30 is 0.8660 and minus 0.5, okay, and this is 0.5 and 0.8, so 0, and let's is of x is 1 1 1. This is your A. Okay, now after multiplication we will get 0.366, and in y 1.366 in 1. Okay, and when we calculate the B dash, now I'll do directly, you will place the rotation matrix over here, and the values 441, okay, and the new values after multiplication we will get the same values we have already calculated, that is 1464 and 5.464. Okay, now let's redraw the figure. That is A dash, where is A dash? That is 0 point x, in x direction it is 0.3, so somewhere in x it will lie over here, let's say this. And where is 1.3? Let's say this. Okay, so this will be the point, and this will be your A dash. Okay, and what is B dash? That is 5, 1.4, 1.4. Let's say this is 1.4. Okay, and let's say this is 5. Okay, and 5.4, this is 5.4, and point is this. Okay, so the new line is generated. Okay, so this is your B dash. Okay, so A dash is this, and B dash is this. Now you can see over here the object is translated as well as rotated. Okay, so by default with the rotation, the translation take place whenever the object is not placed at the origin. Same case goes with the scaling. Whenever the object is placed at the origin, so no translation will take place. When it is placed somewhere else, then by default the translation will take place. Okay, so I hope now you can solve this problem. You are given with a triangle with coordinates A, B, C. Rotate the triangle by 90 degree in anti-clockwise direction. Okay, again the theta will be taken as positive and theta value will be 90 degree. Okay, so in this you are given with 3 points. In this you are given with 3 points A, B and C. You have to calculate AB dash, AB dash, A dash, B dash, C dash. Okay, you have to apply the rotation matrix. Okay, with theta is equal to 90 degree. Okay, and then you have to put the point A and you have to calculate the value of it. Likewise, you will write the rotation matrix over here of order 3 into 3 with theta is equal to 90 degree, as I did in the previous question for a line, and you have to put the old points of B, and what are the old points of B is 1 0. So you will write 1 0 1 over here and you will calculate the values of B dash. Likewise for the C dash, R theta is equal to 90 degree, and here you will write the old points of C to get the new points of C dash. Okay, and after performing the calculation, after evaluating the values of A dash, B dash and C dash, you will draw the old figure and new figure after rotation. So I think you would be able to solve this problem, and if still if you find a problem solving this question, then you can post me the query. Okay, let's go ahead with the another problem. That is related to the shearing. So I told you what is shearing. That is, shearing is tilting an object. Okay, tilting an object in either x direction or y direction. For example, you are given with an object, and if I want to tilt it, or if I want to x shear it by certain unit, so you may get the object in this manner. Means the object is tilted. If I redraw it over here, then it is similar to that of, if you have a book of 2000 pages, and from the top, if you will push it, then it will get little bit of diagonal, okay, or it will get little bit of slanted. So that is called the shearing. So same goes with the y. If I move it in the y direction, then the shearing may take place in y direction. Okay, so this will be your x shear, this will be, or this will be a y shear, and this will be your x shear. So a question is given, that is, you are given with a triangle with points 1 1 0 0 and 1 0. Now you have to apply x shear is equal to 2 and find out the new coordinates of the object. Okay, so for the shearing matrix, I told you, so what are the parameters are involved in the shearing matrix? That if I write the general a b c d t x t y, so these two parameters are responsible for the shearing in x and y direction. Okay, so this parameter is responsible for the shearing x, and this is for the shearing y. So if I just put the values in this parameter, certain values, then you will shear the values, shear the object in x direction. Okay, if I put certain value in b parameter, then you will shear the value or shear the object in y direction. Okay, so that is x shearing and the y shearing. If you make out, for example, b little bit italic in this manner, so it is sheared. Okay, so let's go with the shearing of a triangle A. So you will calculate the new points that are a dash, b dash, likewise we did earlier c dash. For this you have to apply the shearing matrix. Shearing matrix will be, we have to perform x shear with 2 units. So what will be the matrix? 1 1 1 0 0 and 0. Okay, so here you will put the value 2. Okay, and we are not sharing any value over here, so we'll put 0. Okay, so 0. Let me check out. I think I'm missing it. Okay, fine. Okay, so this is shearing. That is this parameter belongs to the X shearing. Okay, now as we are doing now, the hold points of A is hold points of A are 1 1 1 1. Okay, so what will be the value? That will be 1 plus 2 plus 0, and rest of the thing will be 0 1 0 plus 0 plus this one. This will give you 3 1 0. Okay, now B dash, same matrix we will write here 1 2, because we are performing the shearing for X. So the coordinates are 0 for B is 0 0 and 1. What will be the value? 0 0 1. Okay, C dash, we have 1 2 0. Coordinates are for C dash is 1 0 1. Okay, so multiply this, you will get 1 plus 0 plus 0 0 1. Same point. Okay, so these are the values. So after calculation we have got this. Now draw the, let's see the figure after shearing where it lies. Earlier we were having the points. First one was 1 1, so let's say this is 1 1. Okay, 0 0 1 1. Let's erase it. 1 1, let's say this is 1 1. Okay, 0 0, this is the point, and 1 0, 1 and 0. Okay, so this one's a triangle. So I'm just writing the values once again for this. This is 0 0, 0 0. Okay, then 1 1, 2, and this one 0. Let's go with the shearing values. A dash, this is A, we have taken this is A, this is B, okay, this is C. Now let's see what we are going to achieve with the new values. So this is 3 1. Okay, so this is 3 1 3 in direction in X. Let's say this is 3. Okay, and this is 1. So 3 1 is this. Okay, 3 1 is this, and then we have 0 0. This one is 0 0, and 1 0. This one is 1 0. Okay, let's draw the triangle. So here you can see the triangle is X sheared in X direction. The base has remained same, and it is X sheared in X direction. Likewise, when you will apply, you can go for the Y shear. Okay, you can take an example with a square of certain values, and you can apply X shearing and Y shearing with these units and see where the object will lies on your own. I hope you will be able to you are able to understand the concept of shearing. Shearing is simply tilting an object in X direction or Y direction. Okay, so in this, the shape of the object is changed. Okay, so it may be, so if it is a square, it may be converted into the parallelogram. Okay, it will be converted into the parallelogram. So the shape of the object will get changed, but still the parallel lines will remain the parallel lines, okay, as they were in the object. So by doing the X shearing, so what will be the matrix in this case? If I go with the problem 2, so with this the matrix will be 1 1 1. Okay, earlier we have taken the, for the X shear we have kept the value of X shear over here. Now the question B is demanding for the shearing on Y axis. So shearing on Y axis, this parameter will be involved. Here we will write 2, and this parameter will be 0. Okay, and now you will apply the same thing. So I think the object will sheared up by this. तो यहाँ कुछ ऐसा आपको एक object मिल जाएगा. So you have to see where the object will be redrawn after calculating the new coordinates when this figure is sheared on y-axis. So I have shown demonstrated on x-axis. You have to demonstrate, or you have to do on your own on y-axis, as well as take up another figure that is a square. Okay, you can take any value, 1 1 or something like that, 4 4 or whatever you want, and then apply the same unit shear in x and y. See what kind of new object or new coordinates you get as a representation graphical. Okay, so I hope you are able to understand the concept of shearing, and you will be able to solve the questions based on shearing. Thank you all. Okay, welcome dear students. This lecture is particularly concerned with reflection and some problems related with composite transformation and classes of transformations. So we have already gone through the solutions of certain problems related to translation, scaling, reflection, and shearing. Okay, now we'll try to solve a problem related to the reflection. So in the theory part, we have already gone through what is reflection. That is simply a mirroring an object along about x-axis, y-axis, or about origin, or maybe along when y is equal to x. Okay, so in this manner, in this form, we can reflect an object, or we can simply say when we reflect an object, it is rotated by 180 degree. Okay, so let's write those four matrices that is responsible for the reflection in x on x-axis, y-axis, and so on. So reflection along x-axis, if we will say, so we will write a reflection matrix. Okay, that is 1 minus 1 1, and rest of the elements are 0. Okay, so I told you earlier in scaling, while explaining the scaling matrix, that Sx and Sy, when are greater than 0 or greater than 1, then what is achieved while performing the scaling? When Sx is greater than 1, that is enlargement, and when it is Sx and Sy are lesser than 1 and but lies between 0 and 1, then it will be the size of the object decreases. Whereas when it goes beyond 0, that is it becomes negative, then it will lead to the reflection. Okay, so these parameters are responsible for the reflection, and in this, the one of the parameter or both of the parameters are negative, then the reflection will take place accordingly. Okay, so here this matrix is very responsible for the reflection along x-axis. It simply says that, for example, an object is placed over here, let's say this, and when it will be reflected, you will get in this manner. Okay, so likewise, when the reflection will take place along y-axis, the reflection matrix will be, that is minus 1. So the parameters of x will become y minus, and y will remain as it is 0. Sorry, this will be 1, and rest of the elements will be 0. Okay, so this will lead to that you have this, and you will get here some object. This is the reflection along y, and this is x. Okay, so now the reflection along the then about origin, so that will be the, both will become negative, x and y. Okay, so it will put the value over here. It will draw the object over here somewhere. Okay, when reflection, when y is equal to x, then the reflection matrix will be, okay, so rest of the elements will be 0 over here, then the other diagonal elements, this and this, will be involved in the reflection. So then the reflection will take place when y is equal to here, for example. So object will be drawn over here, and the y and x value will get interchanged in this. So let's solve this in one of the problem, and you will find how the reflection will take place along x-axis. In the similar manner, you will do other parts 2 and 3 and 4 of problem 5. So if I write the general matrix, then you will calculate the new points and you will write the reflection matrix and the old point, and this will be applied, this reflection matrix will be applied on all points. So a dash, we are doing reflection here along x-axis. Okay, so we will use the reflection matrix of x, this one. Okay, so I write 1 minus 1 and 1, rest of the elements will be 0. And what is the old point? A old point, that is 3 4. Okay, and what will be the new point after multiplication? That will be 3 minus 4 and 1. Okay, same we will go with the b dash, and we will write the matrix 1 minus 1 1, the rest of the elements will be 0, and we will go with the b old points is 6 4. Okay, so 6 minus 4. Okay, then c dash, reflection matrix x-axis, and c dash is 5 6 1, and the new points you will get the 5 minus 6. So here you can see the simply the points 3 6 and 5 remains the same, the positive values, and the y values have become negative. Okay, so if I draw the figure, okay, so first point, a point is given 3 4. Let's say this is 3. Okay, and this is 4. So this is the point 3 4. Okay, and the next point is the 6 4. So this is 6, and this is 4. This is 6 4, and 5 6. So 5 will lie here, and 6, let's say this is 6. Okay, so this is 6 and 5. Okay, so the triangle will be drawn. Okay, so this is the original triangle. Now we will draw the new coordinates. So new coordinates are a dash is 3 comma minus 4, so 3 is this, and let's say this is minus 4 minus 4. Okay, and this is minus 6 minus 6. Okay, so 3 minus 4, this is the point. 3 minus 4, this is the point, and then 6 minus 4, this is the point, and 5 minus 6, that is 5 is this, and minus 6 is this, and so this is the point. Okay, now we can draw a line to form a triangle. Okay, so here you can see the reflection has taken place along about x-axis. Okay, about x-axis we have reflected an object. So it is a effectively, if we see that it is a rotation about 180 degree. Okay, so if I place the values 180 degree, then this is simply the rotation about 180 degree basically. Okay, so in this also you can see the shape of an object is not changed. Okay, it is simply reflected along x-axis or about x-axis. Likewise we can go with the problem, that is apply the reflection along y-axis. So for this y-axis you are going to use this matrix. So you can redraw the new object, and you will find the object will be reflected along y. Okay, likewise you can go for the reflection above the origin and obtain the new points. Okay, so in y-axis simply what will happen, the x parameter will become negative when you will do so. So I think you will get the points, the x parameter will become negative -3, 4. You will get this, and you will get -6, 4. Okay, and -5, 6. Okay, and likewise when you will do the reflection about origin, then you will get the points -3 and -4. Okay, but you have to solve by putting the matrices. Okay, I'm directly doing, because simply by looking at the matrix, when we do the calculation, you must receive this reflection about x-axis, y-axis, about origin, and y is equal to x. Okay, so you'll get -6, 4. Okay, and this will lead to -5, 6. Okay, and when you will do the reflection y is equal to x, then the values of x and y get interchange. Simply you will get these values 4, 3 and 4, 6 and 6, 5. So 6, 5. So this is the rotation when y is equal to rotation, and y is equal to x means in y is equal to x plane this way. So I hope you are able to understand this. Okay, so in this new points are calculated. I have calculated them directly, but in examination you will not do so. Okay, you have to solve by putting the matrices related to that reflection, that is x, y, origin, or y is equal to x. Fine, so I hope you are able to understand how the reflection works. Now let's move ahead with the another concept. Okay, so this simply shows problem 6 demonstrate there is a polygon with vertices -1, 6, 6, 4, -4, -3, and then find the transformed image when the polygon undergoes translation, rotation, then zoomed out. So this problem is particularly related with the composite transformation. Okay, in composite transformation, what we do, we apply the transformations one after another. Okay, for example, a point is given, 3 points are given to you here. Okay, point P, Q, and R. Okay, if you will not follow the rule of composite transformation, so what you have to do, first you will apply the translation on this. Okay, and then you will receive P dash. Okay, then on P dash you will apply again the translation. Okay, and then again you will receive the Q dash, new points out of it, and then you will apply the rotation matrix on this point. Then you will receive, let's say, V dash. Okay, then after receiving the V dash, then you have to apply the scaling matrix, and then you will get the, let's say, z dash. Okay, so this will be the new point after performing these sequence of transformations one after another. Okay, and again mathematically you have to apply these transformations on this point and on this point as well. Okay, so it will become a complex calculation while performing the transformation when there are successive transformations one after another. So we follow the rule of composite transformation, means this is the complete transformation that has to be applied on each point, that is P, Q and R. Okay, so P, Q, R, on these individual points, this sequence of transformations has to be performed individually. Okay, so we will calculate the composite transformation matrix of these transformations, and we will simply calculate, apply that composite transformation on these points individually. Okay, so what will be the composite transformation of this problem? Okay, here I'm saying that first we have translated an object by 1 4. Okay, so that is 1 1 1. You will write the general matrix, then you will put these values into that general matrix. So but now here I am writing the matrix directly. Okay, to make this video short. 1 0. So tx value is given as 1 and ty value is given 4, and then 0 0 0. Okay, so this is the one translation matrix. Okay, this is one t1 translation, then again it is translated. Okay, so this is given with 2 and 1. The rest of the points are 0, elements are 0. Then the rotation take place. I'm writing c 30 degree, cos 30 degree minus sine 30 degree. Okay, sine 30 degree, cos 30 degree. Okay, then you have perform the scaling, that is zoomed out, it is given here. So the value shows that it will enlarge and it will be a differential scaling. Okay, so 3 4 1. So these parameters are involved in scaling, and you know the scaling matrix now by now, I hope. Okay, so this is the composite matrix and we are representing it as M. So you will multiply it. Okay, after multiplying it, you will get this, you will get this, you will get, after multiplying, you will get M. Okay, so you will get the M resultant matrix over here. So now I'm not solving it, I'm just giving you a hint and you will solve on your own. So one more thing that can be used over here, in place of these two matrices, you can directly write, that is 3 and 5. Okay, by writing that two successive translations are additive. Okay, so by writing this, you can simply write over here, by writing after this, you can simply write that two translations are additive. So the consolidated translation matrix is 1 0 3 0 1 5 and 0 0 1. So the both values in x direction and y directions are added. That is why the one matrix is used over. So it will be reduced to only 3 matrices. Okay, now once you have received the M, now you will calculate the points, that is P dash will be equal to resultant matrix M will be applied to P, Q dash M multiplied by Q and R dash and resultant matrix multiplied by R. So you can see now the calculation has become simpler than that of the previous version. Okay, so P is what? This. Q is what? This point. And what is R? This point. And M is this you have received after multiplying these matrices. This is the resultant or composite matrix that will be applied on these points. I hope you will be able to calculate the new polygon after applying the sequence of transformations. Okay, so let's see another problem related to composite transformation where you are performing the transformation about a fixed point. Here we have taken an example where the transformation is taking place about origin. Everything will be done with respect to the origin. Translation, rotation, then scaling. So this will be done for this triangle with respect to the origin. Now if we want to, let's see another example, and it will help you to explain. See, the same problem has been changed. One statement is added within it, that is simply a polygon is given with three vertices with the same vertices, then find the transformed image about a fixed point. Okay, so now you have to perform the translations, or you have to perform the transformations about this point. Okay, means a point is given 2 3. Now everything has to be done with respect to this. Okay, not with respect to origin. You have given an object. Okay, so for example, the scaling has to be done with respect to this, translation has to be done with respect to this, rotation has to be done with respect to this. Okay, so with respect to this point, the object has to be transformed with these sequence of transformations. Okay, so what steps we follow in when we have to perform the transformation about a fixed point? First we have to bring this fixed point, that is xf and yf, and the same procedure we will follow as we have followed the procedure in scaling about a fixed point and rotation about a fixed point. Okay, so first we will bring this point xf and yf to the origin. Okay, let's say this is the origin and this origin is translated to this point. If origin is 0 0, okay, if this will be translated by, let's say tx is equal to 2, okay, and ty is equal to 3. So what will be the new translation values? So new point, that will be 2 comma 3, means now the origin is here. We are trying to say now with respect to this, now we will bring this point back to this. So if I'll subtract, if I'll do the inverse of the translation, then I can put back this point to the origin. Okay, so I'll do the inverse of the translation, that is minus translation, that is tx minus 2 and minus 3. I'm directly writing the matrices now. Okay, okay, now the point is bring back to the origin. Now all the transformations one after another will take place with respect to origin now, with respect to this. Okay, so first transformation what we have to do, that is translation. So two translations are additive in nature, we can directly write, that is 1 1 1 3 and 5. Okay, and then we have the rotation, that is cos 30 degree minus sin 30 degree, sin 30 degree, cos 30 degree, Okay, then we will write the scaling factors 3, 4, 1. Now, after this, once you have performed the transformations, now you have to put this fixed point back to the original position. Now this is done at the origin. Now when you will put it back to the means the complete matrix has to be translated back. So how will you do so? By just translating the point to the towards the fixed point, that is 2 comma 2 3 1. So simply bring back the fixed point xf and yf to the origin, do the transformation, and place back the origin to its original position, that is 2 3. So now you will have a consolidated matrix M over here. Okay, same you will apply to get the new coordinates, that is P dash M comma P, M into P, Q dash resultant matrix, Q R dash resultant matrix, and then multiplication of the pole points. So after multiplying these matrices, you will get the new points. So I hope you will be able to draw the figure after performing the transformations. You will be able to draw the new figure after doing the transformations. Okay, so these were the few problems which I have taken to elaborate the concepts of this translation, scaling, rotation, reflection, shearing, and composite transformation, simple composite transformation, and also composite transformation when these transformations are done about a fixed point. Okay, so these three problems we have already solved earlier, that is prove two successive translations are additive in nature, two successive rotations are additive in nature, prove that two successive scaling are multiplicative. Okay, so you can easily do in general form. Okay, means it is simply saying that when we have done two translations one after another. Okay, so if it is given that tx1, ty1, and 1 1. Okay, I'm writing the general form and you will multiply it to get the result. Okay, so this is t1 matrix and t2 tx2. Okay, so the resultant matrix will give you ty1 t. Okay, so this will be the resultant matrix. So earlier we have to do that t1 into point. Okay, when once you have got the result, then you have to do the translation to, you have to apply the resultant matrix. Okay, instead of doing so, what you can do, you can use this matrix and directly apply on this point, that is the resultant matrix is M, then M by saying simply two successive translations are additive in nature. So you can directly use this matrix when two translations are applied one after another. Same goes with the rotations and your scaling. So in rotation, you are having the angle theta 1. This is related to sine minus sine theta 1, cos theta 1, sine theta 1, okay, and cos theta 1. Okay, so this is one angle about which you are rotating. Then the second angle is taken. Second angle will be theta 2. So this is rotation 1, this is rotation 2, that is theta 2. Okay, minus sine cos. Okay, so these two matrices, first point is rotated by angle, let's say 30 degree, and then it is rotated by 15 degree. So we are saying simply that point is effectively rotated by 45 degree. Instead of saying that it is rotated by first 35 degree then 15 degree, we are rotating rotating this object or this point by an angle effectively 45 degree. So simply we can write, instead of multiplying two times, we can simply write that c cos theta plus 1, theta 1 plus theta 2. Likewise, we can write minus sine theta 1, theta 2, like cos theta 1 plus theta 2. Okay, then sine theta 1 plus theta 2, 0, 0, 1, like this. Okay, so this shows basically two successive rotations are additive in nature when done one after another. So if an object, अगर हम कोई ऑब्जेक्ट को एक बार में पूरा रोटेट ना करके दो बार में दो एंगल्स में एक के बाद एक रोटेट कर रहे हैं, पहले हम कह रहे हैं कि एक ही ऑब्जेक्ट को हमने पहले 30 डिग्री से रोटेट किया, फिर उसके बाद उसी ऑब्जेक्ट को 15 डिग्री से रोटेट किया, इफेक्टिवली हमने उसको 45 डिग्री से रोटेट किया. So we can use this axiom and we can write this matrix directly, okay, by adding the two angles together. Likewise, when we do the scaling, so the scaling can be multiplied. So in this, you will write the two matrices, that is S scaling x1 scaling sy1, okay, y2. This is its general form. Okay. Now here we are saying that the point is scaled by this value first, and then again it is scaled by value this. So effectively we are saying that sx1, हम दोनों स्केलिंग फैक्टर्स को आपस में मल्टीप्लाई कर सकते हैं और उसको हम डायरेक्टली उसको यूज कर सकते हैं. If you will multiply it, you will get this. So this shows that two successive scalings are multiplicative. तो x फैक्टर्स को अगर मान लीजिए हमें दो स्केलिंग दी हुई है, एक sx1 दिया हुआ है 2 और sy1 दिया हुआ है हमें 4 और हमें sx2 दिया हुआ है 1 और 1 नहीं लेते, इसको 2 ले लेते हैं फिर से, और sy1 दिया हुआ है 3 रखेंगे. सो हमारे लिए इफेक्टिव वैल्यू क्या हो गई, रिजल्टेंट s क्या हो जाएगा हमारा, दैट इज 2 into 2 4 इन x डायरेक्शन 4, और s रिजल्टेंट y क्या हो जाएगा हमारा, s रिजल्टेंट y क्या हो जाएगा 4 3 12. तो इफेक्टिवली वी आर स्केलिंग the object by these parameters. Okay, so we can use this matrix directly by saying that two successive scalings are multiplicative, and in the examination these proofs can also be asked to show that If we are doing two successive translations, they are additive. If we are doing two successive rotations, then they are additive to show. And also you can be asked to prove that two successive scalars are multiplicative in nature. So likewise, you are going to solve the problem. Okay, so coming on to the next slide. So this is very basic thing that I want to discuss with you, that is classes of transformations. So you know the different types of transformation. Now these transformations can be put under different classes or categories. One is called the rigid transformation. When we perform transformation, the distance between the 2 points are preserved and it remains as it is, as it was previously. So for example, when you are doing translation, rotation, and also reflection, so the size of the object does not change. Okay, size of the object does not change, and the shape of the object does not change. Okay, like when we do the similarity transformation, so this is a rigid transformation, everything will remain same in this case. And now similarity transformation, where angle is preserved, where the angle does not change. In this, the distance does not, this distance is preserved. In this, the angle is preserved. So translation, rotation and uniform scaling, that is ट्रांसलेशन और रोटेशन के अंदर और यूनिफॉर्म स्केलिंग के अंदर क्या होता है, आपका एंगल प्रिजर्व रहता है, एंगल चेंज नहीं होता है, ठीक है, एंगल सेम रहता है. सो दैट इज द केस. और एफाइन ट्रांसफॉर्मेशन का मतलब क्या है, पैरेललिज्म प्रिजर्व रहती है, मींस लाइन स्केल कर जाती है वो ऑब्जेक्ट, लेकिन क्या हो सकता है कि आपकी लाइन में आपका लाइन एफाइन ट्रांसफॉर्मेशन का मतलब ये है कि जब आप डिफरेंशियल स्केलिंग करेंगे तो क्या होगा, आपका लाइंस पैरेलल की पैरेलल, शेयर है, शेयर की लाइंस क्या होती है, पैरेलल रहती है. तो एफाइन ट्रांसफॉर्मेशन में आप एग्जाम्पल में देख रहे हैं कि जैसे कि जो स्केलिंग है यूनिफॉर्म स्केलिंग है, और रोटेशन है, ट्रांसलेशन है, ट्रांसलेशन रोटेशन रिजिड भी है और एफाइन ट्रांसफॉर्मेशन भी है. ठीक है, जब हम शेयर करते हैं तो शेयर डज नॉट गिव यू द रिजिड ट्रांसफॉर्मेशन, इट गेट्स टिल्टेड. ठीक है, जो ये टिल्ट हो जाता है. ठीक है, इसमें भी आपकी क्या है, शेप चेंज होती है, डिस्टेंस आपका स्केल करने में, डिफरेंशियल स्केलिंग में डिस्टेंस सेम नहीं रहता है. सो दैट इज नॉट अ रिजिड ट्रांसफॉर्मेशन. Okay, so this is come under the heading of affine transformation, where the parallelism is maintained but the distance may get reduced. Clear? So that is the case with the classes of transformation. Means we can have the rigid transformation, so these are called the translation and rotation, and affine transformation, that where the parallelism is preserved, that is translation, rotation, scaling and shearing. I hope you are able to understand what does it mean, classes of transformation. Okay, so we'll come up with the new lecture that will be covering up the topic that is called the inverse transformation. Okay, so the basic thing that involves in it is simply you have the original points, okay, and you have calculated the new points in the previous version. Okay, now you have the new points, the calculated points with you. Now you want to find out where this object was originally placed. Okay, so you have to do the inverse of those transformations to get the original coordinates out of the calculated new coordinates. Okay, so let's see what it is all about. Okay, so the next topic will be the inverse transformation. Thank you all for patience here.